Right here, we have one tank here. We are studying the pipe in series and pipe in parallel. And we have one tank open to the atmosphere. The difference of level between this tank and this tank is something capital H. And we have connected one base pipe. I will not show the diameter and all those things. This one is pipe number 1 is connected. So for this pipe, this one is point number 1. P1 by rho g 0. P1 by rho g 0. V1 square by 2g 0. Z1 with respect to Z2 is equal to capital H. So on the left hand side I have 0 plus capital H. P1 by rho g plus V1 square by 2g plus Z1. P2 by rho g 0. V2 square by 2g 0 plus Z2 is 0. But is it equal to head loss due to friction only? So whatever the head is available with us, is it entirely lost in overcoming the friction if we neglect the minor losses? Now this one is my one pipe and exactly parallel somewhere here. So I have one pipe here and I have a second pipe here. So in the view you can't visualize that. And I will say that this pipe is parallel to the first pipe. So for this pipe also, is a 1 and 2 are same, is the losses are same. And if we have third pipe like this, now actually they are at the same level. It's very difficult to show me this third pipe. Are these three pipes are parallel? For all these three pipes, is the losses are same. One pipe has a discharge equal to Q1, second has Q2, third has Q3. See the discharge coming at this point is Q1 plus Q2 plus Q3. So we have 1, 2, 3 pipes are like this. So this one is called as pipe number 1, pipe number 2, pipe number 3. For all these three pipe is the point number 1, that is E1 is here and E2 is here. So for all this pipe is HF1 is same as HF2 is same as HF3, and this pipe has a discharge equal to Q1, this has discharge equal to Q2, has a discharge equal to Q3, is the total discharge coming at this point is Q is equal to Q1 plus Q2 plus Q3. Then we have a second pipe like this. And then we have one pipe like this. This is pipe number 1, this one is pipe number 2, this one is pipe number 3. Are these arrangement are in series? So the arrangement will like this: pipe number 1, pipe number 2, and the pipe number 3. So this is the actual arrangement. Pipe number 2, pipe number 3. This point is E1, this point is E2. Is the difference between this figure and this figure. So what are the losses are coming at this point plus this plus this? How are you going to write down Bernoulli? P1 by rho g, that is 0, plus V1 square by 2g, again 0, Z1 is capital H. I am coming to this point, P2 is 0, V2 is 0, Z2 is 0, is it HF1 plus HF2 plus HF3? Means when the pipes are in series, its total head is equal to HF1 plus HF2 plus HF3. And this discharge Q, is it same as this discharge Q, and same discharge is this. So in this case Q is equals to Q1 is equal to Q2 is equal to Q3. So in fact here we are studying one concept that is called as equivalent pipe. Suppose we have a old system for a certain city. Pipe system is like this. Okay, that was the old system, something around 50 years like this, old system. Now we want to replace this system. So when you want to replace the system, then you have to take care that whatever the water supply you are giving to the city now has to be matched first. That should not be affected. And the available head with us are restriction for you. So you have to match this value also. Entire system you want to replace. So if you want to replace this system by entire one pipe, then that pipe is called as equivalent pipe. So naturally, what is available in your store, that you have to select. Normally the pipe of diameter D are available, but of different length. So you have to select that diameter and you have to find out the length, and you have to let this pipe of this calculated length. Then your discharge will not be affected and it will work fine. For this situation is HF1 plus HF2 equal to HF3 equal to this head, then my purpose will get solved. So here equivalent length can be obtained, that head loss for this pipe must equal to head loss for this pipe. That is the equivalent length. So this is HF1 plus HF2 plus HF3. Now advantage is that the discharge for all these pipes are same. So we'll use this equation of Q formula. So this is FLQ square divided by 12 d to the power 5. Rest term I will simply write as summation of F. F is common for all. L is I. All pipe has different length. All pipe has same discharge, square term, divided by 12, and all pipe has different diameter. So in that case, f is cancelled, 12 is cancelled. So will you get the equation as L by d to the power 5 is equal to summation of Li. If you are knowing these three and you are available with diameter d, can you find out equivalent length? Or if you have a length is a constraint for you, can you find out equivalent diameter? So out of the pipe, as per the diameter, your purpose is solved. We have HF equal to FLQ square by 12 d to the power 5. Now I want to solve this situation, so I got this equation. For this I will solve this equation for Q. Q is equal to 12 d to the power 5. Is it multiplied by HF divided by FL, and whole thing power is this. So I will continue my last equation. For this pipe system is replaced by a single pipe again. So my discharge remains same, my head loss should remain same. So we continue with this equation, that is Q equal to what? This equation. Can we replace this first Q as this one? Is it 12 d to the power 5 multiplied by HF? Is it divided by F multiplied by L? Is it whole power is 1 by 2? And on the right hand side, I will go by summation of, is it 12? Is it di to the power 5? HF for all these cases are same, so we do not write I suffix here, divided by, is it F is same for all, and is it Li, and then is this power is 1 by 2. So finally you left with d to the power 5 divided by L to the power 1 by 2. This 1 by 2 and this 1 by 2 will not cancel, huh? Yes. Is equal to summation of di to the power 5 by Li to the power 5, and this one is 1 by 2. Actually this is Li to the power 1 by 2. So basically this term is plus 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 like this. Huh? So that is why this power is not cancelled. So can you calculate equivalent length and equivalent diameter for parallel? So this equation is for parallel and this equation is for series.